So thank you, everyone. Fiona Strens, founder and chief executive of CrowdVision. I'm delighted to be here. I think you heard yesterday several times, actually, that we've got a new strategic relationship with Amadeus, so that's why I'm here. Great opportunity for us, and I hope for you, because it means that as customers of technology products like ours, you'll be able to access the CrowdVision products through the Amadeus relationships and channels that you already have, and understand how the technologies can work together and deliver more value into your airports or operations. I'm going to give you a little bit of background on the company, a little bit of color about where we've come from and how we've ended up in airports. And then I'll talk about the value proposition. So what value is it that CrowdVision delivers to our customers? And then we'll get a little bit more visual, and I'm actually going to show you the product in action and try to give you a flavor of how it works, but also what the end user experience is, what kind of data they can access, what kind of things they do with it. We've also, by the way, I've got my colleague Jason in the room, sitting over there, waving his hand. He's sitting with a laptop that has this system running live. So if anyone would like to see what a live dashboard in an airport operational control room looks like, go and have a look over there. I don't mind, by the way, if you wander around and do that while I'm talking, whatever. Let's make this reasonably informal. So CrowdVision did not start in airports. CrowdVision actually started in Mecca in Saudi Arabia. And it's important that you understand that, because some of the characteristics of our product were defined way back in the 2000s. When we started working, well, the video stopped running. This is not a good sign. Let me see if I can get it to run again. No, okay, it's not going to run that one. When we started working with the Saudi government, and you can see an image here of the type of image of the crowds in Mecca that comes from CCTV cameras. It's pretty dense, it's pretty crowded, it's pretty chaotic, it's actually extremely dangerous. And if the video was running, what you would see would be the embryonic version of the CrowdVision software detecting kind of where the areas of danger are in that space. The co-founder of our business, Anders Johansson, worked in academia trying to understand how crowds behave, how they move, how dangerous situations emerge in crowds. And he used machine vision, computer vision technology very early on to try to spot danger and to provide early warning in a live operational environment. This kind of crowd is extremely dangerous, and 450 people actually died about 15 minutes after that bit of video was taken from stampeding and crowd crushing. So, you know, CrowdVision started for a very good reason, which was to try to save lives. And we have worked now in Mecca for 10 years. We go every year. We've got very large-scale deployments there, and you know, it's a great kind of something we're very proud of, that we keep people safe in Mecca. So it's all about public safety. It's really about live data to inform live, real-time operational decisions. You're going to see a lot of dashboards over the next half hour or so. The one on the left was one of our very earliest kind of data dashboards. You can see it's very Saudi Arabian flavored. Inflows and outflows along the kind of the Jamarat Bridge area, if any of you are familiar with that. And you can see this guy in a kind of control room with his radio, and he's basically looking at a CrowdVision dashboard and saying, whoops, you know, flows are growing too quickly, you need to shut some roads or open some gates or whatever it is. So that's how it all started. Okay, we then went on to a wider set of events, so not just Mecca, but we started working in things like music festivals, sports festivals. And again, you can see typical kind of CCTV images on the left-hand side there. That's a music festival. There's a stage at the top, and you can start to see these colored patterns emerge. So this is our software measuring where people are, how they're moving, using computer vision technology, and in this case, actually detecting mosh pits. So for all you moshers out there, I'm sure there's millions of you, this is a mosh pit detection algorithm. A bit of fun really, but you know, mosh pits are again indicators of danger in these crowded environments. Over here on the right-hand side, we also got involved in the kind of smart city world. So we had some cameras around the Canary Wharf estate, the financial district in London, measuring the flows of people through the streets. And in particular, you know, that's a very secure sort of, it's a target environment for counter-terrorism purposes. So there's a lot of interest in how quickly you can evacuate buildings, what happens to the people, how do they accumulate. And this is a visualization of some of the data that was measured in some of this work. So I'm only showing you this because I want you to understand where we came from. Our product came from this background. It means that we've always started big. We've always tried to measure crowds. We haven't focused on the individual so much as the crowd. And that is very much in the DNA of our company. However, you don't get rich from doing this kind of thing in the event sector. And in 2012, 2013, we thought, where else can we apply this increasingly amazing technology, but actually build a business around it? And we landed in airports. Airports are busy, unpredictable, dynamic environments, 365 days a year, and they need this kind of insight to optimize operations. We now measure 100 million passengers each year going through 3 of the London airports, London City, which although it's very small, is extremely crowded and sort of high value as an airport. Stansted Airport and London Heathrow as well, so that's the biggest one obviously. In a couple of those airports, we're measuring every single footstep of every passenger journey, departing and arriving. So there's, you know, this is really big, rich data, and we're doing that in real time. We measure everything from check-in to security to lounges to gates, and then on the arrival journey, immigration, baggage reclaim, some of the retail stuff, even some taxi lines, so lots of different areas. And we're measuring people, we're measuring the movement of people. So we spent a couple of years really optimizing our product with these customers' feedback. And we now have moved beyond London quite significantly. We have a number of customers in the US. The focus here tends to be at the moment more around security checkpoints, measuring wait times in TSA lines. I think what's coming is probably measuring wait times in CBP lines as well. And you can see some of our customers there on the left-hand side. And indeed, some of them are in the room today. So some of these deployments are whole airports or whole terminals. Some are just a few checkpoints. So the optimization that comes from the data is being used at different levels. And more recently, we stepped out into Asia and the Middle East and just won a couple of big contracts out there. And I'm very much hoping that with the relationship with Amadeus, we start to spread our wings as well. So that's just by background context. Okay, so what's the value proposition for customers? So we're essentially about this smart agenda, smart airports, smart city, smart everything, everything's smart, right? I'm going to tell you what we mean by smart, but basically smart's really about optimization, okay? Optimization of the movement of people through crowded places in our case. It's about making the best use of resources, getting the most out of what you've got, whether that's security lanes or space or, you know, retail environment or whatever it is. Getting more for less, sweating those assets. And fundamentally, it's got to be about customers, in this case passengers, creating great customer experiences. So what's CrowdVision's version of a smart airport? Okay, well, first of all, it's a successful airport. And any successful airport must make itself an airport of choice. You know, passengers have choice, airlines have choice. We can choose now not even between airports, but between different modes of transportation. So everyone's in competition with each other for airlines and for passengers. And a smart airport needs to create capacity to cope with demand. We heard yesterday that you know, passenger numbers are going up at quite a significant rate. So some airports are having to plan for growth and need to be able to have the capacity to cope with those increasing numbers. In the nearer term, like even down to the sort of next 10 minutes and 15 minutes, you don't actually know what's going to happen in terms of demand in an airport. You don't know if a train load of passengers is about to turn up and swamp your check-in hall, or you know whether a transit train's about to arrive and dump several plane loads of passengers in your immigration hall. You may have plans, but plans don't withstand the kind of messy realities of day-to-day life and the type of disruptions that, as you all know, impact airport operations day on day. So you've got to be able to cope with peaks and troughs in the sort of real-time environment as well. How do you do that? Well, you make most use of what you've got. You optimize your assets. So every airport has a number of high-value assets, things like security lanes, things like check-in desks, things like those move-in kiosks we saw yesterday, things like TDC posts or CBP desks. These are scarce resources, they're constrained, and you need to get the best possible use out of those resources if you want to keep people moving through the airport. Equally, some airports have loads of space, but some are very capacity constrained in terms of square feet of floor space. So you want to make the most of it. There's no point having a massive crowded area on one side and an underused area on another side. You need to try and distribute people and improve your layouts and flows. You need to keep people moving, and you need to keep bags moving, and you need to keep them moving in sync with each other, because ultimately you need passenger and bags arriving at the right place at the right time if you want to keep things running to time. Increasingly, you also want to be financially successful. I think gone are the days when, airports were sort of landing strip cost centers and no one really cared about profit. They're definitely profit centers these days. So what do you need to do? You need to run efficiently, similar things to what I've just talked about. You also need to optimize not only your aero revenue, but your non-aero revenue. So things like retail, obvious one, food and beverage, all of that. But we also heard, for example, about digital advertising yesterday, another source of revenue. And there are various ways by managing the flows of people through these environments that you can maximize what you can get from those sources of revenue. And then you need to make smart investments. So like any business, you need to invest in a smart way to save money, but you also, if you've got increasing demand, need to be investing in a way that creates the capacity that you're going to need going forwards. So fundamentally, a smart airport, it's all about removing waiting. Waiting frustrates everyone. Waiting's just bad. There's a lady, I don't know whether she's in the audience, from Atlanta. I was speaking to her yesterday. She asked me what my connection journey was like at Atlanta, and I said it was absolutely amazing. The train worked really well. The staff were really nice and friendly, but I waited an hour and a quarter in a CBP queue, and it totally destroyed my whole experience. I was stressed out. I thought I was going to miss my connection. I wasn't spending money. I was desperate to buy stuff. I didn't have time. Waiting is bad. Waiting frustrates passengers. It leads to people missing their flights, which is not the airline's objective. It undermines revenue optimization, and fundamentally it damages reputation. If you get a reputation for lots of queuing and waiting, it ain't good for anyone. So you want to remove waiting. This is a typical departing passenger journey through the airport. You wait in check-in, right? You wait in security. Then maybe you've got enough time to spend some money, and then you probably get called to the gate at a suboptimal time, and you wait at the gate before you can actually get on your plane. So we're all about trying to help our airport customers, our airline customers, to remove waiting, or at least minimize waiting. Now, you can't do that unless you can measure it. You've got to understand where waiting is happening, when it's happening, why it's happening, how it's happening, okay? So part of our job is to provide the technology that enables people to measure waiting. And once you measure it and you understand why it's occurring, then you can get down to what can we do to deal with it, and start to put actions in hand to either minimize it or remove it. So I think you probably all agree with all of that. Now, how do you do it? Well, we would argue that we need smart airports making smart decisions. And I'm going to talk a little bit about what smart decisions means here. So building on the theme that came across very strongly, I thought, from the introductory sessions yesterday from Amadeus and the Frost and Sullivan guys, the passenger has to be at the heart of this. Decision-making has to be passenger-centric. It's no good just making decisions to please the IT director anymore, or one particular stakeholder in the airport. You've got to put the passenger at the heart of decision-making. You've also got to look across the whole operation and beyond. There's an awful lot of localized sort of decision-making and optimization activity goes in airports. Someone says, I'm going to try and do something about my TSA queues. but they're forgetting that maybe they could take some action in check-in that could relieve the issue, or that it'll have a knock-on effect into maybe the retail environment, for example, if things happen in TSA. So it's about looking across the whole operation, optimizing holistically, making sure you're thinking the end-to-end passenger journey rather than just sort of passenger experience at a spot in time. Fundamentally, it's got to be about using data and evidence. There's an awful lot of anecdotal decision-making, I would argue, I think, in a lot of airports that I've engaged with. I quite often hear the story that queuing happens because someone didn't do something and it's someone else, and everyone kind of has little debates about this. Well, actually, if you can measure it and you have data, data's truth. Data creates conversations. Data enables collaborations. And once you've actually got data, it's an absolutely critical resource to enable things like collaborative decision-making. Once you can do all of that, you can start to learn and continuously improve. You've got a reference point. You know what the data said last week. Now you're looking at what it says this week, and you can start to drive those kind of understanding and that improvement over time. This came up yesterday as well, making smart technology investment decisions in context. There's an awful lot of localized investment decisions made. There's little RFPs with boundaries around them. And actually, when you put stuff in a bigger context, digital strategies, data strategies, making sure you're thinking holistically about how technology and data can play into the airport environment, you can make much better quality decisions and get better outcomes. And then finally, automating where it makes sense. Clearly, there are some aspects of operations that are perfectly capable of being automated and should be, because they're deterministic and no one's going to have a debate. But we've got to understand that the status of artificial intelligence in the world today is not the same as human intelligence. And somehow we've got to find that balance of bringing humans and automation together in decision-making in a smart way. So what we're really about is creating the data that enables smart airports to make smart decisions. We're all about trying to get the passenger with their bag to the plane on time. Yeah? So data to keep people moving. And I think Heathrow actually put this rather nicely. Happy passengers with their bags on time. That's what they want to achieve. Tick. So that's what we help people to do. Okay, so now it starts to get a little bit more exciting because I'm going to show you some moving things and images. Just before I do, I just want you to understand what a CrowdVision deployment actually sort of physically looks like. We use standard, off-the-shelf, so commercially available digital IP cameras. So these are like CCTV cameras. And I don't know whether you can see, but on that picture on the left, there's a pole, and there's some CCTV cameras just hanging off that pole. So that's in Heathrow Airport, okay? They can be more usually, actually, they're located in ceilings. So, passengers are oblivious to them. They're totally unobtrusive. So these cameras get put into the airport environment. It's an upfront investment. You do it once, and then you use the data lots of times for lots of different reasons. Then the video streams from the cameras go across to servers, usually in an airport data center, and CrowdVision software runs on those servers. And I'm going to talk you through what the software actually does and demonstrate it. And then that produces a load of data, and that has to get to users, and users will take it from dashboards, they'll have reporting tools, there's APIs to allow it to be integrated into data lakes or other systems and so on. The other thing I should say is that obviously the airport world is slightly behind quite a lot of the commercial world in terms of this migration to cloud, and CrowdVision is kind of following that trend, so we can actually package our product up not only for this on-premise kind of deployment, but we also have a cloud-heavy version and a sort of edge IoT sensor-heavy version as well. So the software, I'm going to run you through this. It has a detector. This is the clever bit. This is the computer vision. This is where our intellectual property really is. I'm going to show you that. Then we have an analytics layer, which is where we turn all of this clever detection data into actionable things, metrics, KPIs, things that you can actually get your hands around and use to make decisions, and then a whole load of user interfaces as well. So if I just start at this end, you saw this video on the left yesterday. Fisheye lens cameras. So these are just standard digital cameras, but they have a lens that means that each camera can see further. Okay, so you can see around the edge of this camera, around here, that things look very small, whereas in the middle they look quite big. That's the effect of the fisheye lens. Our software takes streams from these types of cameras, and you can see it's putting little dots on heads. So you can see that the software is identifying essentially where the head and torso of a person is, okay? And then it's tracking that person for short periods of time, just to understand about how they're moving, what direction are they moving in, how fast are they going, okay? So where are they, how are they moving? All of that data is written every second into databases and so on, so it's a very big set of detection data. On this side, something a little bit different and very special to crowd vision is the ability not only to detect heads on the left-hand side, but to actually detect the utilization of spaces in an airport. So in this case, I don't know whether you can see it, but it's a automated security lane, and there are two lines of kind of cylinders over here, and these are the divestment points for passengers to get rid of their bags and put them into trays. And there's a member of staff whose job it is to essentially try and get people into these, I don't know if you can see these little footprints here on the floor, line them up so that we've got a whole set of mini queues. Now they're doing this so that they can try to push the volumes of passengers through the security checkpoint and keep the passengers moving as fast as the new super high speed baggage scanning that's going on in parallel with all of this. These red and green sort of cylinder shapes that you can see are just crowd vision constructs to define regions of interest that we want to measure. So every time someone's in one of those volumes of space, it goes red. When they're not in it, it's green. Think ones and noughts in a database, and now we've got a utilization matrix for basically any bit of floor space anywhere in the airport that you're interested in. We set up these cylinders in the configuration layer, the software configuration layer, and we put them around check-in desks, you know, security lanes like this. We put them in immigration desks, roundabout kiosks, anywhere where you want to understand, is there activity, is there a member of staff, is that member of staff processing a passenger in some way or another. Okay, so we detect people and we detect spatial utilization down at the machine vision level. Now, there's no point just looking through one camera. So what we start to do is we stitch the data together. We glue this real-time data together, all those detections, across multiple cameras. Okay? So now we have a single picture of all of those detections in real time over however big you want it. So quite often our deployments have hundreds of cameras, and we're gluing all of that data together in real time. And what you can start to see here is this is now an integration of some of those head detections over this space, and over time you can start to see the footfall of people. You know, how's this space being used? How are people flowing? You probably can't tell it yet, but this is a check-in hall, and in that middle chunk you'll start to see more activity. That's queues forming. And if you watch a bit, you can even see some of the queue maze structure in the detections. And at the front here is where people are getting actually checked in, and then they're exiting around here and coming back. And this is the main flow line in this terminal. So this is quite useful if you just want to understand about the utilization of space overall, whether you've got those crowded areas and those less crowded areas. Now, none of that's very actionable. It's very nice to look at, and you can watch it and have fun, but you can't actually make decisions with it, okay? So the next stage is to define what we call these regions of interest. This blue shape here, we call it a polygon. So in this case, that's a queue. So, you know, we've just drawn the queue on the space, and we say, that's a queue. I want to do queue analytics on that queue. Now, whilst we're still showing some visual stuff here, you can see a heat map building in the queue. The key thing is we've now got some numbers. So we've got these numbers here. We've got the queue occupancy, and we've got the queue time. These things start to be actionable. These are metrics of goodness or problems, and they can start to be actioned in a real-time environment. You can also see at those desks over on this side, these are the sort of outcomes visualized of those cylinders that I was talking about. So we've got one of those configured in front of every desk. So is a desk processing a passenger? Yes or no? Ones and zeros in a database. Now, this is where it starts to get a bit more actionable, is where we kind of lose all the visual stuff. So the visual stuff's over on the right-hand side and all the things you've just seen. But this dashboard over on the left-hand side is where, this is where it becomes actionable. This is where someone in an airport operational control room or someone, you know, with this kind of dashboard on a tablet, maybe a supervisor of a security checkpoint or whatever, can really look and see what's going on, and they can get metrics that matter to them. So number of people in a queue, you know, queue times and so on. And you'll see that there's some green kind of coloring on this. If you look and just let this cycle through, you'll start to see the odd amber and red. So these are where thresholds or targets or whatever, there you go, are being breached. So these are kind of visual alerts, if you like, that something is now going wrong. In this case, this is an example from San Juan Airport, and it's that red box that keeps flicking on there is when the general line of this TSA checkpoint is having a queue time or a projected queue time that's getting too big. So it's a call to action. It needs to be sorted out. And then finally, a whole load of ways of consuming this data. So I've got to put a few examples of dashboards here, but again, if you want to see it live and have a feel for how interactive it is, we've got a live one running over there. Bottom left, Heathrow Airport, a check-in hall. This is a high-level view. At a glance, you can see there's a few yellows and reds, so maybe there's some problems with particular zones in the check-in environment. You can also see these little graphs. I guess you can't really read the legends, but just to give you a flavor, these are volumes of passengers, flows, okay? So number of passengers in 15 minutes or 5 minutes or an hour. And the green bars are kind of the live, what's happening in real time, and the lines they're being compared with in blue and pink are trend data, so we collect the historic data. So it's compared with what normally happens at this time of day, but also the pink line is an airport-imported forecast. So we're taking Heathrow's forecasts that are derived by their in-house forecasting team from all the airline load factors and so on. We're integrating them into this, so you can watch the day unfold live versus trend versus forecast. There's a CDA one up at the top right, so we're deployed in quite a lot of the checkpoints, security checkpoints in O'Hare and Midway. And this is our sort of standard TSA offering. TSA very much in the loop on all of this, measuring all the kind of features of checkpoint performance that you want. So the flows in and out, how many lanes are opening, how long people are waiting for, how long it's taking them to get through the screening process. And actually we can also do some micro analytics, like, you know, are there particular blockages? Are people getting stuck at a particular TDC post and so on? So this is all really actionable stuff for trying to keep people moving through these checkpoints. The bottom right one is London City Airport, which is very crowded and very congested. And the focus really here is how full am I? Am I overcrowded, right? So at the bottom right here, you can see these kind of little circles here. This is showing you, when they're red, that a space is extremely overcrowded, and probably, again, a call to action. So that's live. These kind of dashboards go in operational control rooms on large screens or in other environments. Now, live's only part of it. Obviously, there's a rich source of data here, and this data is being stored and used. So on the right-hand side, for example, we have a classic kind of CrowdVision KPI report, right? So you measure the things that really matter to you, you decide, and then every day or every week or every month or every shift or whatever it is, the same data is presented in the same format, and you can feed it into your plan, do, review cycle or whatever you have, and that drives that continuous improvement process that I was talking about before. So we usually put things like turn-up profiles and queue times, sometimes it's crowding levels, all sorts of different KPIs on this type of report. Over on the left-hand side, quite an interesting one, data to optimize investment. So this is an example of where London City Airport had old-fashioned security lanes and they wanted to invest in new high-speed automated security lanes. So they had CrowdVision baseline data from the old system. They put in one of these new lanes. They used CrowdVision to measure the impact of that. At the beginning, it wasn't that great because they didn't quite train their staff. The processes weren't optimized, but over time, they managed to show with CrowdVision data that they were not only getting 78% more passengers through the lane, they were also taking a minute off the journey time through security, which is massive in their environment. So that was then supported a business case to go and roll out these automated security lanes across both of their checkpoints. So that's an example of data being used to support investment decisions. Okay, I'll just give you a quick case study of London Stansted Airport, and you can see this one running live if you want to. Typical CrowdVision dashboard, spatial layouts. This is the immigration hall, and this very European-sounding airport. It's got E-gates, and it's got EU queues and non-EU queues, and so on. But you can see for each queue, there's a number of people in the queue, and there's a projected queue time. How long people joining the back of the queue are going to have to wait, okay? Now, normally this is all green. You can see a little yellow there, which shows that things might be getting a little bit out of control. In this case, it's because they're about to breach their 15-minute internal kind of target for maximum queue time. So at that point, you would drill down, and you'd have a look and see what's going on. So you get another level of detail. So the whole concept is you can look at it high level, you can drill right down, you can go back up, okay? You can navigate around. And yeah, you can see some things have gone red there. So there would then be a call to action at this point. So maybe some immigration staff would be called off their tea break, or maybe something would be done to try and at least manage customer relationships in that environment, or to redirect flows. These little symbols at the top are whether a desk, in this case, a desk is staffed or not staffed. So a grey cross means there's no member of staff behind the desk. A little green man or a red man means the desk is staffed, okay? If it's green, it means it's not only staffed, but they're actually doing something. There's evidence of passenger activity in front of that desk. Okay, so we've got value-add activity. If it's red, it's got a member of staff behind it, but maybe they're not doing anything. Maybe they're on the phone to their mate, or whatever they're doing. They're hanging around. They're not delivering value. And as I say, all of this data is available historically as well as live to drive this operation. I'm nearly there, by the way. I'll stop in a moment. Also, these kind of projected queue times can be put in front of passengers. It's quite good for managing expectations. If you have a long queue time, passengers prefer to know that in advance. They can prepare themselves for it, okay? So we do a lot of putting these kind of data in front of passengers in Stansted. And the great thing about our data is it's predicted queue time, so it's based on what's ahead. It's not old, kind of outdated queue time, which is what you get in a lot of other systems. So it's actually meaningful. It's relevant in retail environments as well. So we measure a lot of flows in and out of retail units. This is Stansted Departure Lounge. You can see some of the concessions there, Starbucks and Burger King and so on. So that flow in and out data is really useful. If you combine it with point of sale, you can start to understand what's going on in your retail. But also you'll see the green channel, which is the flow channel, and some seating in there. So what Stansted are actually doing is now adjusting the call to gate times for passengers to try and keep the number of people in this environment at the optimal level for both passenger comfort and for passenger spending. Okay, so they can slow it down or speed it up, pull passengers through or just hold them. And that is extremely effective. And then now the data is actually being used. Stansted are about to extend their airport, so a lot of the CrowdVision data, and we find this in a lot of airports that we work with, is actually really valuable when you start to think about expansion options, capital investment, where to put your dollars for maximum impact. So that's me. I'm done. I hope that's prompted some thoughts and some questions. Happy to take questions. Also happy to show you more live as well.
Have you ever done any applications with exit lane breach control with this?
Exit lanes through, sorry?
Breach control, keeping passengers from going from the non-secure to the secure side.
Oh, okay, yeah. So we tend to steer away from kind of compliance type security functions because there's other people and other technologies that do that. I mean, the fact is we can do it, right? But we tend to stick to our sort of core principle, which is we're about helping airports to keep people moving essentially and maximize flows.
We got a mic
But,
here.
no, just another quite a quick response to that, actually, because we're using standard digital IP cameras, there is absolutely no reason why multiple video analytics applications shouldn't run off the same video stream. So while we do the crowding and the flow, someone else could be doing certain security applications and so on as well.
Fiona, it sounds like your technology could be used to provide some fascinating insight into the whole discussion about cost and benefit that I talked about yesterday.
Yeah.
So to what extent can you continue to track individuals as they move through different cameras?
Yeah.
So for example, let's say that Copenhagen has an A340 coming in from Peking. They park it near the Gucci shop, and they would like to know how many passengers actually make their way from that specific flight
Yep.
to the specific shop.
Yep.
Could you do that?
We potentially could, but we don't for some quite good reasons. So we, as I said, we came from Mecca, right? So we're used to measuring thousands and tens of thousands of people, not one or two. Now, machine vision is quite computer heavy, needs quite a lot of compute resource. So it gets very expensive very quickly if you want to track every single individual, even if you can do it. So we choose not to do it. What we choose to do is essentially, if you can imagine you're sort of hovering in a helicopter over your airport and you strip the roof off, okay, at any point in time, you get a snapshot, a dynamic snapshot, because you're still seeing how people are moving as well. And then you get one a second later and one a second later. Now, you can do some pretty cool and clever things with maths to join that data together, and you can make some approximations and you can get some really useful insights of the type that you're talking about. But we're not doing it by, tracking an individual from camera to camera to camera through their journey. One other way of coming at that, because I know this is something that people, like, is taking other sources of data like, mobile app data or whatever, combining with our kind of data, and you get a very rich data picture then.
Okay, if any of you would like to get some more information from Fiona, I'm sure she'd be happy to have a conversation with you after the session. So,
Thank you.
thank you. Let's give Fiona a round of applause. We got about a half hour.